హాయ్ ఫ్రెండ్స్, ఈరోజు మనం గ్యాస్ టర్బైన్స్ గురించి చూద్దాం. గ్యాస్ టర్బైన్స్. ఓకే, సో గ్యాస్ టర్బైన్స్లో మనకి ఫస్ట్ ఇంట్రడక్షన్ మనం చూసుకున్నట్లయితే ద ఐడియా ఆఫ్ గ్యాస్ టర్బైన్ ఈజ్ ద oldest one and its working principle is an improved version of the windmill which was used several centuries back. Okay, and this is coming from this introduction about this, and now we are going to see in gas turbines classifications. Classification of gas turbines. So, though the gas turbines may be classified in many ways, at the following: first one, according to path of the working substance. Okay, that is A is closed cycle so that is called here closed cycle gas turbine. So closed cycle gas turbines. And B is open cycle gas turbines, and C is semi-closed gas turbines. Okay, and now here we are going to see second one, according to process of heat absorption. Okay, heat absorption. Then A is equal to constant pressure gas turbine, and B is equal to constant volume gas turbines. Okay, these all are the classification of gas turbines. Then we are going to see one by one in here. First one is closed cycle gas turbines. A closed cycle gas turbine in its simplest form consists of a compressor, heating chamber, gas turbine which drives the generator, and compressor and a cooling chamber. Okay, so now here we are going to see the diagram. First this thing, so first we are going to see compressor. So here I am going to draw compressor first. So this is compressor, and this is called turbine. Okay, this is connected with the generator. So this one called is compressor, this one called is turbine, and this one called is generator. Okay, now the process is go to see here. Compressor 2, we are going to send here one heating chamber. So now I am going to fix here one heating chamber like this. So it will going like this. Hot air will enter inside the heating chamber and outside. Okay, so this is called the heating chamber. Now the process is going first compressor to this, and here is 2. Then we are going to connect here another one, that is called, here I am going to fix cooling chamber, and this chamber cooling water in and cooling water out. Here is in and here is out. Then now closed cycle. Look at here, 1 2, then 3, then 4. We close this thing, so it will come to entirely closed system, that is called here closed cycle turbine. So now the process is going here. 1 is compressor 2 heating chamber, and 1 to 2 is getting, this is called heating the compressed air, and then here we are going to turbine. 2 to 3 is turbine process, and 3 to 4 is cooling process. Okay, so then here it will called, his one is cooling chamber. ఓకే, ఈ విధంగా మనకి ప్రాసెస్ అనేది రన్ అవుతూ ఉంటుంది. సో దీనికి ఈ క్లోజ్డ్ సైకిల్ టర్బైన్ వర్క్స్ ఆన్ జ్యూల్స్ ఆర్ బ్రిటన్ సైకిల్. ఓకే, సో ఆ బ్రిటన్ సైకిల్స్ ఎలా ఉంటాయి అనేది, బ్రైటాన్ సైకిల్ అనేది మరి ఎలా ఉంటుంది అనేది ఇప్పుడు చూద్దాం మనం. జౌల్స్ ఆర్ బ్రైటాన్ గుర్తుపెట్టుకోండి. గ్యాస్ టర్బైన్స్ ఆర్ వర్కింగ్ విత్ బ్రైటాన్ సైకిల్స్. So now I am going to draw the Brayton cycle, the pressure constant cycle first. So Brayton cycle is coming from pressure constant cycle. So here is, we are going to see this is point 1, and now here is point 2. You take this one, P1 is equal to P2. Okay, so that means here is pressure and this is volume. Okay, and then 1 to 2 is constant pressure, and now here we are going to see 2 to 3 like this. This is 2 to 3 and 3 to 4. Now we are going to see close this cycle like this. Okay, and now here we see P3 is equal to P4. Okay, now here temperature and entropy. Now the temperature and entropy graph here is, entropy is constant, then here temperature will raise 1 to 2. So 1 and this is 2. Then 2 to 3 come to here. This is 2 to 3. And this is constant entropy. So then I put it here 4. So the process is coming to 3 to 4 and then 4 to 1. Okay. So now here we see the temperature differences here is T1. This is called T2. This is called T4. So this is called T3. Now this is called T2. Okay, so this is coming from temperature with kelvins, and now this is come from entropy H. So this is a diagram name is called PV diagram. Sorry, entropy is called S, enthalpy is called H. So then this is called here TS diagram, small s. Okay, and now here we are going to see how to calculate the work done of turbine and compressor. Okay, so here you see work done by the turbine per kg of air. So then that is equal to Wt is equal to Cp into T2 minus T3. Okay, and work required by the compressor per kg of air. Okay, so compressor, now here we see Wc is equal to Cp into T1 minus T4. So then Cp is equal to kilojoules per kg kelvins. Okay, don't forget this units, kilojoules per kg kelvins. And now we are going to see network done. So net work done available. So network done available, W is equal to Wt minus Wc. In first chapter we will discuss about this formula. Okay, and this is fixed. Okay, now this is the closed cycle performance, and now we are going to see one problem about this. Look at here the problem 1. A simple closed cycle gas turbine plant receives air at 1 bar and 15 degrees and compresses it to 5 bar and then heats it to 800 degrees centigrade. In the heating chamber, the hot air expands. And in a turbine, back to 1 bar, calculate the power developed per kg of air supplied per second. Take Cp for the air as 1 kilojoule per kg Kelvin. Okay. So then now we are going to write here given data first. Solution, then given. So P3 is equal to P4, that is equal to 1 bar. Now here this is the diagram. You can draw again this diagram to solve. When you are going to solve the problems, you must draw the PV diagram and the TS diagram. Otherwise we are not going to solve these things, this type of problems. Okay, especially we need these graphs, important thing. So now here we see P3 is equal to P4. That P3 is equal to P4 is given in here 1 bar. Okay, so that hot air expands. You see here hot air expands. Now you can see here is coming the hot air. Where it will be hot air expands? Here, cooling chamber. ఎప్పుడైతే మనకి ఈ హాట్ ఎయిర్ అనేది కూలింగ్ ఛాంబర్లో కూలింగ్ వాటర్ ఎప్పుడైతే లోపల వెళ్తుందో ద రియాక్షన్ జరగడం వల్ల కూలింగ్ అండ్ హాట్ మనకి ఇక్కడ హాట్ అనేది బయటికి వెళ్ళిపోతుంది. Okay, so then the hot pressure is given from here P3 P4, that is equal constant pressure. You see here constant pressure cycle 3 is equal to 4. And now we are going to see here another one T4, that is equal to 15 degrees Celsius is given, and then that is equal to 15 plus 273, that is called 288 Kelvin. So why? Because we need Kelvins only, not degrees Celsius. Okay, so that's why we are converted into Kelvins. And now here we are going to see P1 is equal to P2, that is called 5 bar is given. So how we will get this thing? And now here and compresses it to 5 bar. సో ఎక్కువ మనకి ఈ ఎయిర్ అనేది కంప్రెస్ అవుతుందో అక్కడ మనకు వచ్చేసరికి ఏంటంటే 5 బార్ అనేది జనరేట్ అవుతూ ఉంటుందని చెప్పేసి చెప్తా ఉన్నారు. Okay, so then heating chamber. Now here we are going to see 1 2 2, and here is pressure will be increased in here. So then that will come to here. No. 1 to 2 is called constant pressure term, but here is compressed air. The compressed air is entered into the turbine. Then here we see 5 bar. Okay, so T2 is equal to 800 degrees Celsius. So 800 plus 273, that is equal to 1073 kelvins. Okay, and now we are going to see here Cp. Cp is equal to 1 kilojoules per kg Kelvin. So the PV and Ts diagram for the closed cycle gas turbine, okay, is here, and then T1 and T2 is T1, T2 is raised, but here this is very near the temperature. T1 and T3 is very closely. Look at here, T1 and T3 is very close. So we are going to take consider this T1 is equal to T3. Okay, T1 and T2 temperature of air after isentropic compression and expansion. That's the at points 1 and 3 respectively. So we know that here can take this is compression and this is expansion. Now okay, just you put it like this, and then now we are going to know about in here what is that. Okay, isentropic expansion. Now here we are going to see in isentropic expansion 2 to 3, this is called isentropic expansion, and this is called 1 to 4 is coming from isentropic compression. Okay, and now we are going to see here T1 T4 is given, so T4 is given, and now here we are going to see. Okay, here we are going to see, yes, T4 is given. Now we are going to see here T3 you need to find, and then I am going to take this is called isentropic expansion. Okay, I am going to take this isentropic expansion. So isentropic expansion 2 to 3. Okay, so then here T3 by T2 is equal to capital T, that is equal to P3 by P2 gamma minus 1 by gamma. Now here P3 is equal to 1, P2 is equal to 5, gamma is equal to 1.4 standard value, and then here also 1.4. You can solve this, you will get the answer here 0.630. So now T3 is equal to 0.631 into T2. Okay, and T2 is given here. See, T2 is given. So then substitute this T2 value in here. T2 value 1073, that is equal to 677 kelvins it will come. Okay, so now similarly I am going for isentropic compression. Where is isentropic compression? Come to this diagram, TS diagram. Now here 1 to 4. So this 1 to 4 is called isentropic compression. Then okay. So that's why we are going to draw these two pictures in here. Okay, right. Now here isentropic compression. So isentropic compression is called 4 to 1. And now here 4 to 1. So what happened? T4 by T1, that is equal to P4 by P1. That's gamma minus 1 by gamma. So P4 is equal to 1 and P1 is equal to 5. So 1.4 minus 1, 1.4. Okay, you can solve this one. You will get some amount of answer here, 0.631. You see here, not we are very close but not is equal. Okay, so here it is not equal to 0. Example, you can solve the same answer will come means this is equal, T1 is equal to T3. Different answer it will come means, okay, you can change not equal to T1 is not equal to T2. Then we will see this how it will work. Okay, T1 T4 divided by 0.631. So it will come 677 kelvins or any different answer we will see. So T4 is equal to 288. See here, T4 is equal to 288 kelvins, and then here I substitute, and now 631. Then solve this thing, you will get the answer 456 kelvin. So look at here, the temperature will difference. This is T3 and this is T1. So temperature will different. So that is the thing is T1 is not equal to T3. So the isentropic here it will come this picture TS diagram 1 and 2. So that is the difference. Okay. So the temperatures are not equal. Any temperature is not equal. Some temperatures are raising and up and down fluctuations is there. Okay, right. And now we are going to see work developed by the turbine. Work developed by the turbine. So Wt is equal to Cp T2 minus T3. Okay, so that is equal to Cp is equal to 1 and T2 we know, T3 also we know, and now this here we are coming to here is all kilojoules per seconds. So this is work done per turbine, and now we are going to see work required by compressor. So work required by compression, and then see here Wc is equal to Cp T1 minus T4, and then that is equal to 1 into 456 288. So that is called here 168 kilojoules per seconds. Okay, and now this you can take 122 and 223. So 223 is coming from the picture, main picture. 223 is turbine, 421 is compressor. That's why we are going to take the temperature differences between in here T1 minus T4 and T2 minus T3. Okay, that's the work done in here to both. Right, and now here we see therefore net work done. We are going to see to find net work done. So net work done, W is equal to WT minus WC. We know the relation here. See here, net work done. Okay, W is equal to WT minus WC. And then we are going to substitute the values in here. WT, yes, WT is here 396 and WC is here 168. So then calculate these both. We'll get around 228 kilojoules per second. So now here we are going to see power developed. Then power developed is equal to work done. So now that is P is equal to 228 kilowatts. This is the final answer. Okay, and since here kilojoules per seconds is equal to kilowatts, that means joules per seconds is equal to watt. Okay, this the units relationship is most important thing. Okay, the unit conversation is very important. So that's why you should learn the unit conversions is must. Okay, and this is the procedure to solve the closed cycle. In next the gas turbine with intercoolers. ఒకవేళ ఫర్ ఎగ్జాంపుల్ ఇంటర్కూలర్స్ కనుక అరేంజ్ చేస్తే గ్యాస్ టర్బైన్స్లో ఏమవుతుంది అనేది మనం we will discuss in next class. Okay, thank you.